We're going to talk about some of the group 1 metals in terms of its trends, the flame test, some examples of chemical reactions involving group 1 metals, and also some of the uses, some examples of uses. Let's get down to it. As we mentioned previously in other units, mainly in the periodic table and its trends, we've talked about the trends of group 1 elements and as you go down the group. Now, to recap, we can understand that in general, the density increases as you go down the group. And that is true with the exception to potassium. Why? Well, this is the way how potassium kind of binds together in a specific amount of volume. Okay? The reactivity of alkali metals also goes up when we go down the group, and that's because of the shielding effect as well as the distance of the valence electron to the nucleus. The melting point of group 1 elements goes down as we go down the group, and the reason is because the valence electron is just way far away. The hardness also goes down the group because of the distance of the valence electrons to the nucleus when all these metal elements are bonded metallically. Okay, when it's metallically bonded. Right. Flame test. Now, ions, metal ions, right? When it's excited, the electrons will jump energy levels. Okay, it will jump energy levels, and then when it goes down, when the electron goes down, it emits light, and this light can be in the form of colors that we see during our flame test. Now, here are 3 examples that you can learn. First is lithium. When the lithium ion is ignited or burned, it emits a red or crimson color. So it's like dark red, almost bright, bloody red in color. Sodium ion, on the other hand, emits out a yellow orangey flame, okay, when it's excited, when you put it in under a flame. And potassium ion, on the other hand, will emit a purplishly lilac color, all right? Kind of like this color that I've used here. All right, reactions of group 1 elements. Now, group 1 elements will readily react with cold water, okay? So, lithium, when you put it in cold water, what's going to happen is that lithium is going to float on water, and it's going to float, and react steadily. And what you're going to make is lithium hydroxide, and the byproduct will be hydrogen gas, all right? Sodium, when you put it in cold water, will react more violently, more strongly. Okay, not violently, but more strongly. It will jump a little bit more rigorously. And also, you make sodium hydroxide. The byproduct again is hydrogen gas. Potassium, when you put it in the presence of cold water, it's going to jump more violently and react. You're going to make potassium hydroxide and hydrogen gas. Now, when we react group 1 elements with air or oxygen, it's going to tarnish very quickly. If you just expose a freshly cut surface of an alkali metal, it's going to tarnish very quickly because an oxide layer is formed. And this oxide layer is a nice coating of the whole entire metal surrounding the perimeter of the entire metal piece that you have. And that oxide layer is going to stick, and it's not going to be easily flaked off or removed, so it forms kind of like a protective oxide layer. And if we were to react group 1 elements with acids, just don't do it because it's going to be violent. Boom. All right. Now we're going to talk about reactions of group 1 elements with chloride. With chloride now, it turns out if you react group 1 elements with chlorine, you're going to get solid alkali metal, and you're going to mix it with and burn it with in the presence of chlorine gas. And this is quite an expensive method and to do. So it's not a preferred method that people make chloride compounds out of. But if you were to do it, this is what you'll do, is that you will make 2 lithium atoms mixing with a chlorine gas to form lithium chloride. Okay? And this will be the gas, this will be the solid, and what you should get like a vapor or some sort that's actually little particles of solid. Okay? And when you react it with sodium, you'll also get the same thing. Okay? And if you react it with potassium, you'll also get the same thing. Now, these are not an efficient way to make these chloride compounds, but hey, that's just the chemistry of it. All right, finally, whoa, I don't want this to drop again like last time. Some uses of alkali compounds. Now, classic example is sodium chloride. We've used that people use that as preservatives back in the days, and we still kind of do it when we want to make jerkies, when we want to make preserved fruits or vegetables or what sort. Yes, we can use sodium chloride. It's a natural preservative, so that's kind of cool. Potassium nitrate, it's the precursor or the stuff that's inside gunpowder. So, boom, nice. Sodium bicarbonate, we see lots of it. It's basically baking soda, and it's used for baking or a cleaning agent. Sodium hydroxide, very important precursor in the industry, and is used for testing for metals. And pure sodium, boom, is used as the heat transfer coolant in nuclear power plants. So there we go.